All right, so we're going to continue with laws of exponents. And there's really just two more rules that I've got to teach you. And I'm going to teach you these rules simultaneously. Okay, so as I'm teaching you one of them, the other one's going to kind of come into the problem, and we'll have to do that rule as well. Okay, so these two rules they don't go together, but they can be taught together. So one of them is called the power rule, power to power rule. And the other one is called the negative exponent rule. All right, so let's start with the power to power rule. Basically, the way you're going to know that you're going to need to use the power to power rule is because you'll see like a whole expression, okay, written in like parentheses. Okay, so I don't know, I'm going to make some stuff up like that. And then it'll be raised to a power. Okay, so the part that's letting you know that this is a power to power rule is because you'll see this. You'll see the parentheses of something being raised to another power. Okay? What the power rule states is this. These are the steps that you're going to use when you're having to use the power rule. You're going to have to raise the base, not multiply the base, but raise the base to that power. And then you're going to have to multiply the exponents. And it might not make a lot of sense right now, but we're just writing the rules right now, and then we're going to actually do some practice problems. All right, so raise the base to that power and multiply the exponents. I'll tell you what that means in a little bit. Let's start with the negative exponent rule now. The negative exponent rule is literally telling you exactly what it says. The exponent is being negative, okay? It does not like where it's at, okay? So for example, if you have anything that is raised to a negative exponent, that's how you're going to know, oh, I have to use the negative exponent rule here, okay? Anytime you have a negative exponent at the end of your answer, your final answer, it is telling you, I'm not happy here. I'm unhappy. Okay, you've got to move where it's at. You got to move it from where it's at because it's unhappy there. Okay, so let's make a little note. Negative exponents are unhappy where they are. So you must move them to the opposite side. Okay, here's what I mean by that. Let's take that b negative 3. b negative 3 is unhappy. To make him happy, he's on top right now. Because remember how every number, anything, can be made a fraction by simply putting a 1 at the bottom, right? So that b is unhappy on the top. So to make him happy, you got to move it. You got to do the opposite, sort of like the reciprocal. So you got to go like this. Put the 1 on top, and now put the b3 on the bottom, but he's no longer negative because you literally moved him to where he would be happy. So the exponent, the actual number stays the same, but now you can leave it as a positive 3 because you made them happy. Okay? Same thing goes for what if the negative is already at the bottom? Well, it's still telling you it's unhappy. And it's unhappy at the bottom. So now let's make him happy by moving it to the top. And this one, remember, is just going to equal this because you don't need to put the 1 at the bottom. So that's what I mean by the negative exponents rule. They're just unhappy where they're at. We just got to put them on the other side. Okay? So that's the power rule. That's a negative exponent rule. So now let's practice with the power rule because you need to understand what raise the base means. Okay? So let's start with a simple one. Let's say I have 3x squared y cubed raised to the 3rd power. So notice I see my parentheses and my exponent. So that tells me, hey, do the power rule. Well, the power rule says to raise the base. This is the base, guys. I am going to raise it to the 3rd power, meaning I'm going to do this. I'm going to take my base and I'm going to raise it to the 3rd power. Remember this from like elementary? 3 to the 3rd power is really 3 times 3 times 3. So what are we going to get when we raise 3 to the 3rd power? 3 times 3 is 9. 9 times 3 is 27. So check, we've done this part. We raised the base to that power. Now we've got to multiply the exponents. So I need to take this and I need to multiply times that and times that. So I need to write my x and I need to do 3 times the 2. That gives me a 6. And then I need to do the same with the y's. 3 times 3, that gives me a 9. And there's your answer. Raise the base, multiply the exponents. Let's do another one. Negative 4 x y squared z 4 all raised to the, let's do 3rd power again. Okay, raise the base. And again, why is this the power rule that I have to do? Because of the parentheses and the power over here. So I'm going to take my base and I'm going to raise it to the 3rd power. So that means I'm going to do negative 4 to the 3rd power, which means I'm doing negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4, that's positive 16. And then the positive 16 times the negative 4, that's negative 64. Once you do that, you are going to finally do the multiply the exponents. So I'm going to take this and I'm going to multiply it. Oh, what's the exponent here? Remember, if you don't see it, it's because it's a 1. So you're going to multiply 3 times 1. That gives me 3. 3 x's. Do it with the y. 3 times 2. That gives me a 6. And now with the z's, 3 times 4. That gives me a 12. So there's your final answer. Okay. What if we had let's see, 4 or 5 M3 and 6 all raised to the negative 2. Okay. All raised to the -2. Well, I see a negative exponent, right? So what it's telling me is that all of this is unhappy being on the top. All of this is being raised to a negative exponent. So all of this is unhappy on the top. So the first thing I need to do is take care of this. That little negative is telling me it's unhappy. So I'm going to have to flip it. I'm going to have to do 1 over 5m cubed n to the 6. And now that 2 is no longer negative. I made it happy. So that's the first thing I had to do. Now I can continue with my power rule. 1 over, I have to raise the base. So 5 squared is the same thing as 5 times 5, which is 25. And now I can multiply my exponents. 2 times the 3 on the m gives me 6. 2 times the 6 on the n gives me 12. So there's your final answer. And finally, what if I have something like this? 3a -2 b3c all raised to the 4th power. So I see the power rule. So I am going to raise my base to the 4th power. So I'm going to do 3 to the 4th power, which is 3 times 3 times 3 times 3. Well, I know that 3 times 3 is a 9. And then here's another 3 times 3, that's 9. And 9 times 9, that's 81. So now that I've raised my base, I can multiply my exponent. I can take that 4 and multiply it times -2. That's going to give me -8 on the A. Then for the B, 4 times 3, that's going to give me 12. And for the C, 4 times imaginary 1, it's going to give me a 4. But this is not my final answer, although I've done all the steps I need, because at the end on my final answer, I end up still with a negative exponent, which means that guy's unhappy. He's unhappy on the top, so guess where he goes? He's going to go to the bottom. So my final answer is going to be like this. 81 is happy where it's at. You never move those, okay? The B12 is happy where it's at. The C4 is happy where it's at. It is the A negative. He was unhappy. So once I move him, he becomes happy. So he's no longer negative. Now that's your final answer. So this is your power to power and your negative exponent rule mixed together. Okay. So now I want you to try a couple of problems. So now you try. So do one like this, where super easy. 3x squared y3z raised to the 2nd power. And how about 4, or let's do 2 raised to the 3rd power. Okay, so try those. All right, so now after you're done with those, hopefully you can fit it all on one page instead of having to turn it. But I want a picture, proof that you wrote all your notes down, and then you attempt these two. Okay, so tomorrow we're going to practice not just the power rule. Well, maybe I'll just stick to the power and the negative, but I might throw in the product and the quotient and the zero rule all at once also. Okay, so we'll practice tomorrow together. All right, guys, see you tomorrow.